Now this question is asking about the amplitude. We're also going to sketch these graphs to help us see. But if you think about your parent graph of sine of x and cos of x, what would a number out in front do to it? Stretch or compress vertically or horizontally? Vertically, because it's outside of the function. So in this first one, in part A, it's going to compress it by 2/3. Can you see that your maximum value was 1 and your minimum value was -1? But when you compress it by 2/3, what's your maximum going to be now? 2/3. And what's your minimum going to be? -2/3. So when we go to graph it, that value in front is going to change our amplitude. In fact, our amplitude is going to be 2/3 now instead of 1. Can you see that the distance between the center line and your maximum is 2/3 now instead of 1? How we graph it is the same way as we graphed before. We still mark one full period, which is 2 pi, along here, divided into 4 equal sections. And sine of x. Did sine of x start in the middle at a maximum or a minimum? Started in the middle, right? So that's why we memorized it. It started here in the middle. You could also think, well, what is sine of 0? What's our y-coordinate when the angle is 0? It's 0. And so sine starts here. Sine starts in the middle going up. So you go to your maximum, minimum, middle, back to minimum, and back to the middle again. So now we have a new maximum and a new minimum. And this is our graph with a new amplitude of 2/3. So one of the things that you're going to hear me talk about often is that sine starts in the middle going up. Cos starts at a maximum. We can think of the 0 and the 1, but once we start stretching things and moving things around, it's not always going to start at 0 and it's not always going to start at 1. But a sine graph always starts in the middle going up. A cos graph starts at a maximum. In B, though, we don't have just a normal cos graph. We have a negative cos graph. So in part B, we want to graph -4 cos of x. What does that -4 do? Stretches it by 4, and it flips it over the x-axis. So we've got a vertical reflection and a vertical stretch. So if our maxes and mins of our parent graph were -1 and 1, now they're going to be -4 and 4. So we're going to label 4 and -4 on our y-axis. We're going to go to our x-axis. We're still going to make one period, which is 2 pi. Now, if a cos graph normally starts at a maximum, where will a negative cos graph start? At a minimum. So we know that it's going to start here at a minimum. We can go through all of our points. It goes from our minimum to our middle, to our maximum, to our middle, back to our minimum. The amplitude is the distance from the center line to a maximum, or the distance from a center line to the minimum. What is our amplitude here? So when we say our amplitude is always a positive value because it's a distance. So the amplitude is 4. Okay, I'm going to give you 3 sine and cos graphs. You're going to tell me what the amplitude is without graphing them. Here's the first one. What's the amplitude? 5. Good, 5. Here's the second one. What's the amplitude? 3/4. Here's the third one. What's the amplitude? 31. Careful, right? Because you're tempted to say negative 31. Yes, the amplitude is always that number in front of sine or cos, but it's always positive. That negative 31 means that it would be a sine graph. Instead of going up to start with, a negative sine graph would go down to start with. But our amplitude is just that value in front. Okay, questions to do for practice are 3A and B, 4, 5, and 9. And we'll work on those